Hey, welcome back. Let's take a look at Lewis dot structures. But this time, let's take a look at some more advanced kind of molecules when dealing with Lewis dot structures. So in order to address this, let's go ahead and create a series of rules or steps that we'll take every time. First, we are going to add up all the valence shell electrons for each element or atom in the molecule. So if it was nitrogen, we would take 5, and then oxygen would be 6. We'd add those up. That would be 11. So however many there are times the number of valence. Then we'll add all those up for each element. If there is a charge, we will include it. Most likely we'll be talking about negative charge, so the more negative it is, the more electrons we will add to our total. Next, we're going to draw out the molecule. We will use the symbols for each element. The least electronegative element will go in the middle. This is almost always the very first element in the compound. So an example would be CO2. Carbon would be in the middle, and you can also see that carbon is the first element in the compound CO2. So that won't take a lot of figuring out. Now that I've written down the correct symbols and I have them organized, I'm going to begin using the valence shell electrons. Each valence shell electron will be represented by a dot. The first thing I want to do is put 2 dots between the central element and the element surrounding it. So if I had CO2, I would have an oxygen on the left, dot dot between carbon, oxygen on the right, dot dot between carbon. Now let's go ahead and use up the other electrons that are left over. So we would start with whichever element that's not the central one that you would like, and then work your way around. So in this case, start with the left. I put dots on the left oxygen, then I go to the right oxygen. Once I've done with both oxygens, then I put the rest of the dots on the carbon in the center. Now, my last step. I have used up all the valence shell electrons, and they're on the molecule. I will now take a look at the center atom. It probably will not have 8 electrons, but it needs 8 electrons because of the octet rule. So I will choose one of the atoms surrounding it and take 2 of those electrons off. I will move them between one of the atoms and the central atom to give the central atom 8 electrons. If I need to move more, I will, but I need 8 electrons around the central atom. Let's take a look at the example of O3. We know that oxygen has 6 valence shell electrons. We know that there are 3 oxygens here, so 6 plus 6 plus 6 is 18. Now we have our number of valence electrons. Now let's draw the symbols for the elements. This one's kind of easy because they're all the same, so oxygen has to be in the middle. Put 2 dots between each one, 2 electrons, and then begin to fill in the rest. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, if you begin to count, you will notice that the oxygen does not have 8. It only has 6 electrons. So, I'm going to remove the 2 here, then I'll change color so you can see it, and I will move them to here between the central oxygen and this outside oxygen. Now, the middle oxygen has 8 electrons, and this is what it would look like. It can also be written with the double bond on the other side. So either way is technically correct. In reality, it goes back and forth between these two, which can also be represented with a dotted line to represent that the double bond switches back and forth. This is called resonance. Next, let's take a look at a molecule that actually has a charge on it. So this is going to be ionic. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons. There is 1 extra electron that is coming from the charge. It's another extra valent electron. There are 3 oxygens, 1 nitrogen, and obviously one of the others. So we're going to add up 5, 18, and 1, and we will end up with 24 valence electrons to work with. So nitrogen is the first element in the molecule, so I will draw it in the middle, and then I will draw the oxygens around it. Next, I will put 2 dots between the central atom and each of the other atoms, and then I will use up the rest of my electrons going around each of the other atoms. Once I have filled in all the electrons there, if there's any left, I can go to nitrogen, but there's none left. I've used them all up. And we can see that nitrogen does not have 8. It only has 6 electrons. So I remove 2 from here, and now I will show you where they go right here. And now you can see that nitrogen has the 8 electrons that it should, and the drawing will look something like this here. And since this is an ion, we're going to have to put brackets and add a charge. That's it. See you next time. Bye-bye.